Hey guys, I hope you're doing well today. In this video, we're going to review the concepts necessary for success in Chapter 4. So this is our Chapter 4 lab material. After you watch this video, you should be good to go to complete the Chapter 4 lab assignment in my math lab. So the first thing we're going to review is the order of operations. I know you've worked with these before, the PEMDAS. Go ahead and say it. I know you know what it stands for. Please excuse my dear Aunt Sally. We've all used this, but we may have forgotten how to actually utilize them in a problem. So let's take a look at the proper order. If you have grouping symbols or parentheses present, you should always work inside grouping symbols first. Oh, let's go with a little pink. All right, so first, come on, pen, work with me. All right, I have done something. Fixed. Okay, work inside grouping symbols first. After you've worked inside your grouping symbols, or when you're working inside your grouping symbols, this is the order that we're going to perform the operations. We will always do exponents first. So if there are any exponent operations, you got to hit all of those next. Or actually first, if you want to say that. So I'm going to look, if I have any exponent operations, do that first. Then I'm going to go left to right and see if I have any multiplications. And as I move left to right, I'm going to take care of multiplications. I'll also take care of any divisions as I move left to right. So I'll hit the multiplications, I'll hit the divisions moving left to right. And after exponents, multiplications, and divisions are taken care of, then I'll move again from left to right, take care of any additions. I'll move again from left to right and take care of any subtractions. So how about we practice the order of operations with the following examples? Excuse me. So let's take a look at this first one. I've got lots of sets of grouping symbols. It's 3 plus a little brace, and then 9 minus, then a bracket with a 10 minus an open parenthesis with a 13 plus a 7, close the parenthesis, close the bracket, close the brace. Lots of grouping symbols, and so we have to work on the innermost set of grouping symbols first. So we are going to look, the innermost grouping symbol has a 13 plus 7. So I have to do that operation first. So 13 plus 7 would give us what? Yeah, 20. So I've got a 20 for that set of grouping symbols, so I can drop that set of grouping symbols because I just performed its operation. So let's bring down what's left over. I have a bracket to the right. I have a brace to the right. Now to the left of it, I have the minus, the 10, a bracket, a negative, a 9, a brace. So from left to right, it reads 3 plus brace, 9 minus bracket, 10 minus 20, close bracket, close brace. I still have grouping symbols. I've gotten rid of the parentheses. I now need to get rid of these brackets. So inside the brackets, I have 10 minus 20. So let's go ahead and do that operation. So 10 minus 20 gives me a negative 10. So my brackets are now gone. What's in front, or I should say to the left of that negative 10, is another minus and a 9 in front of it. I'm going to carry everything else down because I haven't done anything with the other operations. I'm still working inside my grouping symbols. So what I see from left to right is 3 plus a brace, 9 minus, and then I have a negative 10. How do you handle 9 minus a negative 10? You remember what happens with double negatives? Minus a negative means we're basically adding. So double negatives turn into addition. So this last set of grouping symbols that I have, the set of braces, and inside those braces is 9 plus 10. So let's remove those grouping symbols by adding the 9 to the 10, which gives me a 19. All grouping symbols are gone, and my final operation is 3 plus 19. Well, that result would be what? I'm just going to write it here, 22. We have to follow this order to work any arithmetic type problem. So let's look at the one to the right. I've got negative 5 plus 2 times negative 3 minus 11. So I don't have a ton of grouping symbols where I have to work my way inside out, but I do have some multiplications and additions and subtractions. So I see a multiplication, and in my order of operations, I have to do multiplications and divisions before additions and subtractions. So let's hit this multiplication first. And the multiplication is 2 times a negative 3. So I'm going to bring down the minus 5. I'm going to bring down the plus. And I'm going to multiply 2 times a negative 3, which gives me a negative 6. And then I'm going to bring down the subtraction of 11. So what I have is a negative 5 plus a negative 6 minus 11. So again, we're going to go from left to right. I've taken care of all multiplications and divisions. I didn't have any division, but I took care of all multiplications and divisions. After that, I'm going to do additions and subtractions going from left to right. So as I go from left to right, I see the first operation is negative 5 plus a negative 6. And a negative 5 plus a negative 6 gives me a negative 11. Then I'll bring down the subtraction of 11. Now I've got one operation left, which is a negative 11 minus 11. Well, when the signs are the same, remembering with your addition and subtraction, you basically add them. So a negative 11 minus 11 is a negative 22. And that would be the answer for example 2. Let's look at this next example. I have within parentheses 7 plus 10, that whole quantity squared. And what I'd like to do is compare that problem with the one to the right of it, where it says it's 7 squared plus 10 squared. It's very easy to think that these two problems are the same, that they result in the same answer, but they don't. If I have 7 plus 10 in parentheses with a square on the outside, that is not the same as 7 squared plus 10 squared. And let's just do this. Let's do the order of operations. So the 7 plus 10 is in parentheses, so I need to add those up. So 7 plus 10 would give me 17. Then I need to raise that result to the second power. Well, 17 squared, let me pull out my calculator and square that, is 289. So 17 squared gives me a result of 289. Let's look at the other problem, which is 7 squared plus 10 squared. Well, 7 squared is a 49, and 10 squared is 100, and when I add those up, I get 149. So we see that 7 plus 10 all squared is not the exact same as 7 squared plus 10 squared. This is just reinforcing the concept that when you have an exponent outside a set of grouping symbols and there's addition or subtraction in there, you cannot put the square, you cannot distribute the square to each element inside. That is not algebraically sound. Okay, so let's check out these last two examples. And these you're going to have a calculator available to you. So the first one is 20,000, open parenthesis, 1 plus 0.11, close parenthesis, third power. Well, I have grouping symbols, so I need to work within those grouping symbols first. So I don't do anything with the 20,000. I add the 1 to the 0.11 to give me 1.11, and then that's raised to the third power. So it's 20,000 times parentheses 1.11 to the third power. What do I do next? Exponents. Exponents are done before any multiplications, divisions, additions, subtractions. So I need to take care of this exponent part first. So I'm going to bring down the 20,000, and I'll pull up my calculator and raise 1.11 to the third power. And notice on my calculator that I pulled up on my computer, in order for me to get an exponent of 3, I use this y to the x button. Your calculator might have an x to the y, but that allows you to raise to a power as far as this calculator goes. So 1.11 to the third power is 1.367631. What do I need to do with that result? Well, you'll notice, actually, let me copy it down. 1.367631. The operation between that and the 20,000 is multiplication. So now I need to multiply that result times the 20,000. And when we're doing problems like this, we do not round until the final answer. Okay, so what's nice is I still have the 1.367631 on my calculator. So I'm just going to take that result and multiply it by 20,000. So I'll hit times 20,000. Press equal to, and here is the result. So 27,352.62. 27,352.62. Let me make sure I copied that correct. Okay, yes. So in using your calculator, you'll need to be able to have a calculator that will raise to a power. And depending on your calculator, there are different ways it can be done. So why don't you practice using your calculator on the problem to the right of it. Work it out, and then see if your answer matches with the answer I obtained. So see if you get the same answer that I got. I got 15,205.699, and I rounded the 0.699 to 0.70. If you didn't get the same result that I got, go back and check your calculator entries, making sure that you use the order of operations where you had to do 0.056 divided by 4 first, then add a 1 to that, then raise that amount to the 80th power, and then take that final answer and multiply it by 5,000. Okay, let's look at the second to last topic. Let's just review solving some equations. And we've done this in one of the previous labs, so we're just going to review solving these first two types. And these are set up like proportions. Whenever you have a fraction equal to another fraction, that's called a proportion. And the way we solved proportions in a previous video was we just cross-multiplied. Cross-multiplying is used for solving equations. So I'll have an 8 times an x, which gives me an 8x, and a 10 times a 4, which gives me a 40. So I have 8x equal to 40, and I'm trying to solve the equation for x. And so to get rid of the 8 in front of it, the opposite of multiplying by 8 would be dividing by 8. And I have to divide both sides by 8. So we get x equal to 40 divided by 8, which would be 5. So we've solved that equation for x. You use the same procedure for the problem to the right of it, and then pause the video and then come back and check your result. So this proportion problem is 20 divided by 22 equal to x over 33. We're going to cross multiply 33 times 20, which gives me 660, and 22 times x, which gives me 22x. And to solve for x, I divide both sides by 22, giving me x equal 30. Let's look at a couple of other equations we need to solve, just recalling some algebraic concepts. Here I've got 6x minus 15 equal to 32. I need to get the 6x by itself, but there's a subtraction of 15 next to it. So I need to add the 15 on the other side to get it away from the 6x. And when I add it to the other side, I'm going to add it to a 32. So 32 plus 15 gives me 47. Now this is in the format like the previous problem. I've got 6x equal 47, and to get rid of the 6, I'm going to divide both sides by 6. So we would just say the answer is 47 over 6. If it asked for a decimal approximation, we would just go to our calculator and divide 47 by 6. Let's look at the next one. 3x plus 2 equal negative 13. Work on that one, pause the video, see if we get the same result. Did you get x equal negative 5? Hopefully you did. That is the correct solution. We had to get rid of the addition of 2 by subtracting 2 on the other side. Negative 13 minus 2 gave us a negative 15. The result is 3x equal negative 15, and so to solve for x, we had to divide both sides by the 3. And negative 15 divided by 3 is negative 5. Okay, finally, the last few problems. Now, you got practice on this information in Chapter 3, but we're just going to review some percentages. So if I had a question, what is 75% of 262? What operation would you need to use or set up to solve this? Take the 75%, convert it to a decimal. It would be 0.75. The word of means to multiply, so it'd be 0.75 times 262. And now I can calculate 75% of 262. If I wanted 41% of 7, it would be 0.41 times 7. And finally, 8% of 900. 8% would be 0.08 times 900. Now, I'm going to need to put units on my answers because it's saying 75% of 262 people and 41% of 7 kilograms, 8% of $900. So I need to make sure that I put units on my answers. So find those values. Seven. So see if you get these answers. For the first one, I get 196.5 people, but that's a problem because we can't have a half a person. So the 0.5 on that answer does not make sense. So how about we round that up to 197 people? That's more feasible. For the next one, I get 2.87 kilograms. That's reasonable. And the next one, $72. That's reasonable. And notice that I have units on every one of those. So good luck with this assignment. You shouldn't have any problems completing it. But if you do run across any problems, please let me know. I am happy to help.